So before I start, I welcome you for this particular student orientation program on virtual laboratory. One suggestion before I start with my session: if you people are working with your laptops, you can try to use this particular virtual laboratory. அதுக்கு முன்னாடி இந்த virtual laboratory அப்படிங்கறத பத்தி I have told you very clear idea about what is a virtual laboratory, which is nothing but virtually we are going to work on virtually we are going to work on the particular equipment without doing it physically. Okay, இதுதான் அதோடைய மேஜர் அப்ஜெக்டிவே. ஓகே, ஸோ அப்போ இதனால் நம்மளுக்கு என்ன சார் பெனிஃபிட் அப்படின்னு கேட்டிங்கன்னா, திஸ் பேண்டமிக் சுச்சுவேஷன், இந்த பேண்டமிக் சுச்சுவேஷனில் ஒரு பர்டிகுலர் கான்செப்டை நான் லேர்ன் பண்ணுறதுக்கு இட் இஸ் வெரி வெரி ஈஸி. ஸோ தட் இஸ் ஒன் ஆஃப் த பிக்கஸ்ட் அப்ஜெக்டிவ் ஆஃப் திஸ் பர்டிகுலர் விர்ச்சுவல் லேபார்டரி. ஓகே, now let me share my screen so that from where we have to start அப்படிங்கிறது உங்களுக்கு கண்டிப்பாக தெரியும். So I hope the screen is visible to you. This is how I have been started, sir. This is how I have been started. Let me come back from the beginning. So just simply I have given V lab அப்படிங்கிறத மட்டும் தான் சார் கொடுக்குறேன். So I'm googling it. Okay, sorry for the interruption. Okay, so just if I google it V lab அப்படின்னு மட்டும் நான் கூகுள் பண்ணா போதும் சார். We have a first website, we'll be having it as vlab.co.in. So vlab.co.in. If you simply get into the link, so this is our particular website which is been created by the initiative of a Ministry of Human Resources Development. This has been now converted into Ministry of Higher Education. ஓகே, ஸோ இவங்களுடைய ஒரு இதில் தான் என்ன ஆயிருக்கு அப்படின்னா, திஸ் பர்டிகுலர் விர்ச்சுவல் லெபார்ட்டரி ஹேஸ் பின் கேம் அக்ராஸ். ஸோ இதுக்கு பின்னாடி வந்து நிறைய பெரிய டீம் இருக்குப்பா. பெரிய டீம் அப்படின்னா ஃப்ரம் வேரியஸ் ஐஐடிஸ், ஃப்ரம் வேரியஸ் என்ஐடிஸ், ஃப்ரம் வேரியஸ் ப்ரைவேட் யூனிவர்சிட்டிஸ், everybody come together which has been created this particular website. Okay, so if you come across this, what is the objective அப்படிங்கிறதெல்லாம் கொடுத்துருப்பாங்க. But we want to go directly in what we need. So if you want to see, you can see here the broad areas of virtual laboratory அப்படின்னு பார்த்தீங்க அப்படின்னா, the different domain we are having the particular virtual laboratory. But I want to concentrate more on mechanical engineering. So if you go into this particular mechanical engineering, we are having particular thing. Okay, let us see what are the laboratories available. So I'll be coming back to this. I'll be coming back to this particular page once again, since my particular today's session is going to come from physics laboratory. Okay, I have been already open it, but I want to know that what is available in our particular virtual laboratory. You can see here material response microstructure mechanical, which has been created by IIT Kanpur, CAD laboratory IIT Kharagpur, virtual laboratory and multi-phase flow IIT Kharagpur, mine ventilation IIT Kharagpur, robotics laboratory IIT Kharagpur, remote triggered virtual lab and automotive system IIT Kharagpur, plant metabolic pathway IIT Kharagpur, rotary machinist, mechanical system, model waste, dynamics of machine new. So you are having one laboratory, kinematics of machinery laboratory for this semester, for which you have most of the experiments here. Metal forming and virtual laboratory, it is a manufacturing laboratory. Mechanics of machine lab, machine dynamics and vibration lab, again it is a dynamics laboratory. Vibration and aquatics, again it is a dynamics laboratory. Micro machining, advanced machining. Okay, so fabrication laboratory, general purpose and production shop. So plenty are available. So plenty of virtual laboratories we have not even having in our colleges. Few of the machines which we are not having in our colleges can also be virtually done. Okay, so let me open any one and I will tell you. This is one of our laboratory which is called as a micro machining laboratory. Micro machining அப்படின்னா என்னன்னா, you know that obviously in our college we are having drilling machine, we are having computer numerically controlled machine, CNC lathe as well as CNC milling, அதாவது CNC horizontal and CNC vertical ரெண்டுமே நம்ம வச்சிருக்கோம். The minimum diameter which can be machined drilled with the help of it வந்து பாத்தீங்க அப்படின்னா ஒரு 1 mm னு வச்சுக்கோங்க. எக்ஸாம்பிளுக்கு நான் சொல்றேன். மைக்ரோ மிஷினிங் லேபார்ட்டரியோட மெயின் பர்பஸ் என்ன அப்படின்னா, the machining can be done in a micro level. So 1 micron is equal to 0.001 millimeter. அந்த மைக்ரான் லெவலுக்கு நம்மளால மிஷினிங் பண்ண முடியும். ஓகே, இப்போ உள்ள நான் என்ட்ரு ஆனதும் this particular lab was created by College of Engineering Pune. அவங்களால என்ன பண்ணியிருக்காங்க, இந்த லேப் கிரியேட் பண்ணப்பட்டிருக்கு. ஓகே. ஸோ இதில் போய் நீ என்ன பண்ணலாம், யூ கேன் கோ ஃபார் லிஸ்ட் ஆஃப் எக்ஸ்பெரிமெண்ட்ஸ். இந்த லிஸ்ட் ஆஃப் எக்ஸ்பெரிமெண்ட்ஸில் பார்த்தீங்க அப்படின்னா வாட் எவர் த லிஸ்ட் ஆஃப் எக்ஸ்பெரிமெண்ட்ஸ் இஸ் அவைலபிள் அண்டர் திஸ் பர்டிகுலர் லெபார்ட்ரி அப்படிங்கிறது இதில் விசிபிளாக இருக்கும். ஓகே, திஸ் இஸ் ஹவு ஈச் விர்ச்சுவல் லேப் உட் பி. இந்த மாதிரி தான் எல்லா விர்ச்சுவல் லேபார்ட்டரியுமே இருக்கும் அப்படிங்கிறத நான் சொல்கிறேன். So to start with, I am going to explain one particular concept related to our laboratory today, which is nothing but metrology and measurement. Then I will go with one out of scope. Okay, so for which I am going back, I am going with the other domain. I am going with the other domain. Okay, so kindly wait. I want to go with the, because it is available in this Vernier caliper and micrometer. You have been you people has been already studied in your particular so I don't know what is this lab actually. I know only physics laboratory. Okay, so this is again been created by Amirda University, which is a private university, which names O Labs. So it is also again coming under this MHRD only. You can see here Amirda, everything which has been created by them. Okay, so likewise we are also going to create one laboratory for the benefit of the students. Okay, so you may come across many of the experiment which you have did in your school studies. So I will share you the particular link in your chat box, which you may be utilized. I have been shared the same through Canvas also. In your Canvas it is available. I will share the home page of the virtual lab also, which you can utilize for your reference. Okay, so this is also have been sent out to you. Okay, so coming back to this O lab. So O labs are which is been created by Amirda University, which has been funded by Ministry of Electronics and Information Technology. They have been created the laboratory for the school students, for which they are having it for physics. So under physics, if you come across class number 11, I repeat again, for class number 11 you can find out two very important exercise, which is nothing but Vernier caliper and screw gauge, or which is called as a micrometer. அது மைக்ரோமீட்டர்னு சொல்லலாம், otherwise we can call it as a screw gauge அப்படின்னு சொல்லி சொல்கிறாங்க. Okay, to find out which, let me enter into the particular exercise. See, can anyone tell me what is the least count for a micrometer or a screw gauge, sir? Can anyone tell me what is the least count or for a micrometer or a screw gauge?
0.01.
Yes, very good. 0.01 millimeter. Okay, so now I am going to do the same exercise. We have completed this exercise already in our experiment number 1. I hope you can see the image, which is nothing but a micrometer or a screw gauge. Okay, micrometer or a screw gauge. Okay, so to start with the exercise, you can see here theory, procedure, animation, simulator, viva voice, video, resources and feedback. Okay, to do with what you are going to do is the content of this particular theory is available, and how to do experiment, how experiment has to be done. So that has been given detailedly over here. Okay, how that particularly 0.00, so here they are given in centimeter, not in millimeter. Here they are given in centimeter, and here you are having in millimeter, 0.00 0.01 millimeter. Okay, so the very important thing in case of a virtual laboratory is a simulator. In animation, what will be happening is they will be having a recorded video how this particular experiment has to be done. Okay, let me play it for a few seconds. I hope the audio is available.
Screw gauge. Let's
No, sir,
understand the working of a screw gauge. The main parts of a screw gauge are stud, screw, frame, pitch scale, circular scale, thimble, and ratchet. Aim: to find the volume of a lead shot, a wire in an irregular.
So this enables the people who are unable to see By even only hearing this particular video, it is very easy. It is very easy to do a particular exercise. But the very important thing in the virtual laboratory is a simulator. So what is actually a simulation, sir? Can anyone tell me what is a simulation?
Online performing of a task.
Online performing of a task. Otherwise, we can say that we are designing one thing and we are looking in how it is working. Am I right? It is called simulation. I'm going to simulate how it is going to work. Similarly, you can see here. This is my particular virtual laboratory exercise for screw cage or a micrometer. So where you can see here they have given a least count in two ways, 0.01 millimeter or 0.005 millimeter. Least count அப்படிங்கிறதுக்கு உனக்கு தெளிவா தெரியும், which is nothing but the minimum or the least value which can be measured by a particular apparatus. அதுக்கு பேர் தான் least count. இப்போ நான் least count வேல்யூ எவ்வளோ செட் பண்ணியிருக்கேன் அப்படின்னா 0.011 செட் பண்ணியிருக்கேன். இப்போ நான் என்ன பண்ணுறேன், இங்கே ஏதோ ஒரு ஆப்ஜெக்ட், ஒரு வயரையோ ஒரு கிளாஸ் பிளேட்டையோ என்ன பண்ணணும், நான் மெஷர் பண்ணணும். இப்போ கிளாஸ் பிளேட் அப்படின்னு நான் செலக்ட் பண்ணிட்டேன். இப்போ இந்த கிளாஸ் பிளேட்டை என்ன பண்ணுறேன், now I have been placed the glass plate here. I hope it is visible to you. Can you see a arrow here? உங்களுக்கு arrow தெரியுதா சார் இங்க? You simply press up. Can you see the thimble is moving? Can you see?
Yes, sir.
Yes. When the thimble touches exactly the glass, you can see how to take a reading. Can you see, sir? Can anyone tell me what is the main scale reading, sir? See here, this is 0, this is 1, this is 2. Can anyone tell me what is the main scale reading?
2, sir.
Yes, very good, 2. And yes, 2. And can anyone tell me what is the division which is coinciding? See, this is 20, this is 25, and what is this value actually?
26.
Yes, very good.
26.
Exactly the 26th division is coinciding with this particular main scale reading. So now how to find out the exact value? 2 plus 26 into 0.01. Can anyone tell me what is the value? 2 plus 26 into 0.01 millimeter. Can anyone tell me what is the value? 2 plus 26 into 0.01. So what is the value?
2.26 mm.
Very good. So this is how it can be done. Okay, see, I'm having a result here actually. Yes. What is the value told? 2.26.
26.
Okay, now what I'm going to do is I'm going to check. So it is telling it is wrong. So let me go with 0.01 number putting 2.25 27. So this is how you can check your value. Okay, let me check again. Now I'm using other component. Now it is 1 2 3 4 and 33. So 33 into 0.01, which is nothing but 0.33. So it is 1 to 4.33, and let me check the value again. This try again. Okay, let me tell you what is happening here actually. So this is how we have to do a virtual laboratory here. Do you understand, sir? Okay, similarly like this, I'm having one more experiment which is related to our particular Vernier caliper, which is similar to that of our laboratory. Again, you can see we have a theory for Vernier caliper. We have a procedure how to do the particular exercise. See, they have been very clearly mentioned. If it is one Vernier scale division and 10 Vernier scale divisions, so how it has to be done, everything is given very clearly, and they have been doing the thing. So let us go to the simulator directly, because it is very important for us, because we want to verify it very clearly. Okay, now I am taking an iron block. Okay, I am taking an iron block and I am trying to move here. Okay, so now you kindly tell me, see here, this value is 4, this value is 4.1. it is actually coinciding here. So the 4.1 oda எந்த division எனக்கு coincide ஆகுது அப்படினு பாத்தீங்கன்னா in the 10th thing. So before which we can go and see in our procedure. See here, it is very clearly given here. See, determination of Vernier constant least count எப்படிங்கிறது 0.01. so நம்ம யூஸ் பண்ற least count வந்து பாத்தீங்கன்னா எவ்வளவு? what is the least count for Vernier caliper?
0.02 amount.
Yes, 0. so நம்ம இங்க யூஸ் பண்ற வேல்யூவை விட நம்ம என்ன பண்றோம்? நம்ம கம்மியான least count யூஸ் பண்ற டிவைஸ் வச்சிருக்கோம், which is nothing but 0.02 millimeter. okay, definitely வந்து நமக்கு error இருக்க போறதில்ல, because we have been calibrating. so இதுல என்ன இருக்கு அப்படின்னா, இந்த particular exerciseல நமக்கு என்ன advantageனா, tabulation is been created there. for example, so main scale reading வந்து சென்டிமீட்டர்ல எவ்வளவு, Vernier scale reading வந்து சென்டிமீட்டர்ல எவ்வளவு, Vernier scale reading into least count, and what is the total reading. for example, we have to take best of 3. அப்ப ஒரு ஸ்பெசிமெனை நான் எத்தனை தடவை எடுக்கணும் அப்படின்னா, I have to take thrice. okay, as per this particular virtual laboratory concept. okay, see here, I can do it. I can create a new table. I can make it as a, this is serial number 1, and what is the main scale reading. okay, what is the main scale reading, and what is the Vernier scale reading, and what is the Vernier scale reading into least count, and what is the total reading. and finally I can, if I have taken 3 values, I can, if I have taken 3 values, I can take the mean value. so now I ask you a question. so previously we have been having a video, now we are having which is very closer to the physical work. அதாவது என்ன அப்படின்னா, வீடியோல வந்து ஒரு laboratory பண்றதுக்கும் இப்படி which is nearer to the physical நீயா பண்ற மாதிரி இருக்கிறதுக்கும் என்ன டிஃபரன்ஸ் இருக்கா இல்லையாப்பா? this is what virtual laboratory. is there any difference or not? sir, whether we are having
Different.
Yes, sir. Yes, sir.
yes, we have a difference. okay, I hope now you might be understood, the importance of a virtual laboratory. okay, so the only thing is, it comes to you only when you try to practice. நீங்க இத பிராக்டீஸ் பண்ணால் மட்டும்தான் இதோட இம்பார்ட்டன்ஸ் எல்லாமே புரியும். இப்போ உங்களுக்கு பாத்தீங்க அப்படின்னா, இந்த மாதிரி எக்ஸ்பெரிமெண்ட் ஓகே. for example, people are trying to create a virtual laboratory for thermal engineering also, because it is a very biggest task for us. for example, you are having other laboratory which is called a thermal engineering also. in that thermal engineering, very small experiment is also consuming more time if we go for a videographing. okay, so for example, I don't know what is the experiment you have, whether you have any experiment such as a wall timing diagram and port timing diagram, whether you have that experiment in your thermal engineering.
Yes, sir.
Yes, sir.
That can be very
Sure.
easily done. Yes, that can be done very easily with the help of a virtual laboratory, but it is been under construction. That experiments are still under construction, and the people are doing it. so okay, so this is what about a basic introduction. what I think இத நீங்க ஏற்கனவே உங்களுடைய சப்ஜெக்ட்ல உங்களுக்கு ஃபேக்கல்டி சொல்லி கொடுத்துருப்பாங்க நினைக்கிறேன். am I right or wrong? yes or no?
Yes, sir.
okay, so now the important thing, so இது வந்து நம்ம laboratory சம்பந்தமா இந்த ரெண்டு எக்ஸ்பெரிமெண்ட் இருந்துச்சு. so I went inside and I have been shown you this particular laboratory, but now I want to get into my one of the favorite area where I have been worked. இந்த virtual laboratoryல நான் எப்ப எது எடுத்தாலுமே இந்த particular concept நான் அந்த இடத்துல நான் எடுத்துருப்பேன். so this is one of the virtual laboratory which is nothing but a micro machining laboratory. இந்த micro machining laboratory அப்படின்னா என்னங்கிறது நான் ஏற்கனவே முதல்லயே சொல்லிட்டேன். நான் இந்த laboratoryல என்ன பண்றாங்க அப்படின்னு பாத்தீங்கன்னா, they are doing a micro machining which is nothing but a micro level machining. okay, இதுக்கு வந்து ஒரு சப்ஜெக்ட் இருக்கு. the subject is called as a advanced machining process or unconventional machining process அப்படின்னு ஒன்னு இருக்கு, which is your elective paper in your final year. உங்க final yearல வந்து அது வந்து ஒரு elective paper. சரிங்களா? இப்போ சிம்பிளா ஒரு கான்செப்ட்டை மட்டும் நான் என்ன பண்றேன், எக்ஸ்பிளைன் பண்ணிட்டு I try to wind up. இதுக்கு நான் என்ன கான்செப்ட் எடுத்துக்கிறேன்னா, electrical discharge machine. have you heard about this electrical discharge machining, sir? இத பத்தி தெரியுமா? if you know, you tell me, otherwise I can explain it. otherwise I will go with the wire electrical. where is WEDM? yes, I will go with this wire EDM. if whenever you go to any virtual laboratory, அதோடைய biggest perspective என்ன அப்படின்னா, you have what is the aim and objective of a particular experiment, and you have a pre-test. இந்த pre-test அப்படிங்கிறது எதுக்கு அப்படின்னு பார்த்தீங்கன்னா, before you get into a particular knowledge, if you learn certain knowledge, what is your prerequisite, உனக்கு இதுக்கு முன்னாடி அதை பற்றி என்ன தெரியும் அப்படிங்கிற விஷயம் உனக்கு ஒரு டெஸ்ட் வைக்கிறாங்க. Then they have a theory about what is a particular machine. Sir, wire EDM, what is a wire EDM அப்படின்னு பார்த்தீங்கன்னா, the abbreviation for wire EDM is nothing but electrical discharge machining. So with the help of an electrical spark, the material is eroded. Okay, so you know that obviously electrical is conductive with the help of a metal. ஒரு metal மூலமா என்னால என்ன பண்ண முடியும், ஒரு electricity conduct பண்ண முடியும். With the same metal, if I go with the same pole, எனக்கு என்ன ஆகும்னா, it creates a spark. பொதுவாக நியூட்ரலையும் ஃபேஸையும் நான் கனெக்ட் பண்ணேன் அப்படின்னா எனக்கு என்ன ஆகும்னா ஒரு ஸ்பார்க் உருவாகும். With the help of that spark, I can erode the material. என்னால் என்ன பண்ண முடியும்னா மிஷினிங் பண்ண முடியும் அப்படிங்கிறத கண்டுபிடிச்சாங்க. அதுக்கு பேர் தான் EDM அப்படின்னு சொல்லிட்டு. அதோடைய அட்வான்ஸ்மெண்ட் தான் என்ன அப்படின்னு பார்த்தீங்கன்னா வயர் EDM. அந்த வயர் EDMல என்ன பண்ணுவாங்க அப்படின்னா, they have one single wire through which electrical current is passed. Similarly, that wire is used for machining. Okay, so this theory part is available in all the virtual laboratory. Whatever you want to learn about the particular machine is available in the theory part, and then the very important thing is the experimental setup. So this is the actual machine, sir. This is the actual machine what we are going to work, where we cannot go and work physically. என்னால் என்ன பண்ண முடியாதுன்னா, I cannot go directly, I cannot operate the machine, and I cannot take the reading. But instead of that, I can go with the simulator. So what is a simulator? Simulator is nothing but the same work which is going to done by a machine is going to be done. I hope you can see this is the work of a particular machine which you have to machine. This is the wire where electrical current is passed. This is called dielectric fluid, which is used here to remove the machined material. So what happens actually, this wire is been electrified. Electrical current is passing through this particular wire, and because of the spark created between this workpiece and this wire, the material is eroded. With the help of a computer numerical control, அது மூலமா நம்ம என்ன பண்றோம், இந்த மூவ்மெண்ட்டை கண்ட்ரோல் பண்ணி இந்த மிஷினிங் அப்படிங்கிறது நடக்குது. Now let us see, without operating the machine, let me find out by giving an input parameter, எனக்கு output parameter என்ன ஆகுதுன்னு பார்க்கலாம். Let me take one example. இப்போ லேத்னு எடுக்கிறீங்கன்னா speed is a input parameter, feed is a input parameter, depth is a input parameter. Can anyone tell me what is the output parameter from a lathe operation, sir? What is the output parameter you will be measuring in your lathe exercise? Or simply a turning, or what is the output you will be measuring?
Diameter, sir.
That is the dimension. Other than that, output என்ன அப்படின்னு பார்த்தீங்கன்னா, have you heard about the word surface roughness? You have been studied in your metrology, I think so. Okay, surface roughness or surface finish அப்படின்னு சொல்லுவாங்க. So for which நான் என்ன பண்ண போறேன்னா, I'm going to perform an experiment. இதில் few of my input parameters are set. சார் நான் 0ன்னு கொடுத்த வரைக்கும் I doesn't have any input parameter. See here, once I give number of trial, I'm having the voltage value, I'm having the machining time value, I'm having T on and T off. So what is T on and T off அப்படின்னு பார்த்தீங்கன்னா, you'll be having here a graph. And the T on and T off என்ன அப்படிங்கிறது என்ன அப்படின்னா, you may study it in your electrical drives and control, pulse on with, pulse off with. அப்படின்னா என்ன சார் அப்படின்னு கேட்டிங்கன்னா, you know that in alternate current we have the electrical curve in this particular manner. ஸோ எனக்கு எப்படி இருக்குன்னா, my current will be in this particular manner. அதாவது ஒரு குறிப்பிட்ட டைம் வந்து எனக்கு ஆனில் இருக்கும், அடுத்து ஆஃப் ஆகும், அடுத்து ஆன் ஆகும், அடுத்து ஆஃப் ஆகும். இந்த மாடுலேஷன் தான் இங்கே கொடுத்துருக்காங்க. ஓகே, டு ஸ்டார்ட் வித் நான் என்ன பண்ணுறேன் அப்படின்னா, ஐம் கோயிங் வித் த ப்ளே பட்டன். ஸோ சி 2 3 4 5 6. I hope you can see in the right hand side what is happening once I have been playing. So what is happening அப்படிங்கிறது தான் இங்கே நடந்துக்கிட்டு இருக்கு. ஓகே சார், இதுலேருந்து நான் என்ன சார் தெரிஞ்சுக்கிட்டேன் அப்படின்னு கேட்டிங்க அப்படின்னா, you can see RA value which is nothing but the surface roughness value in a micrometer, which is 2.66. Okay, now I hope you may be completed your strength of machines laboratory and your thermal laboratory, where you have to draw a graph. But see how it is very easy. See here, I'm going to draw a graph between pulse width on versus MRR. Can anyone say what is MRR? உங்கள் மேனுஃபேக்சரிங் டெக்னாலஜியில் நீங்கள் கண்டிப்பாக படிச்சிருப்பீங்க சார். இதில் ப்ராப்ளம் கண்டிப்பாக சால்வ் பண்ணியிருப்பீங்க சார். வாட் இஸ் MRR? Anyone?
Material renewal rate.
Yes, very good. Material renewal rate. So now I am going to draw the graph between T on and material renewal rate. If you simply press, a graph will be drawn, it will become. Sir, actually there are two lines in. Can you see the difference? This is a blue color line and this is a red color line. The blue color line is the experimental value and the red color line is the theoretical value, where I am comparing the theoretical value with the experimental value. So to show the difference, what I am going to do is I am going to increase the number of experiment and I am going to show you the graph only for the difference purpose. So now can you see the difference in the graph? So you can see this blue color value is the experimental value and this red color value is the theoretical value. So I doesn't even visited the place where the machine is available. I doesn't even operated the particular machine, but I have been conducted the exercise, I have taken the output and I have been plotted the graph. This is the one beauty of the virtual laboratory. So for example, if I want to say here many of them may not doesn't know about what is a wire EDM, but we have learned few things about wire EDM. You may have some concept in it. நான் சொன்னதை வச்சு உங்களுக்கு கண்டிப்பா புரிஞ்சிருக்கும். ஒரு வயர் இருக்கு, அந்த வயர் மூலமா கரண்ட் போகுது, அந்த வயர் மூலமா மிஷினிங் நடக்குது. மிஷினிங் ஆனதுக்கு அப்புறம் அதோட அவுட்புட் என்னங்கிறது நம்மளால என்ன பண்ண முடியுது? We can see it here. So this is the benefit of this particular virtual lab. So இதே மாதிரி we are having plenty of exercise in our particular virtual laboratory. So it is our objective for you to go across all this laboratory and come across all this laboratory, and you can come with an idea, sir, this virtual laboratory can be created by our college. If you want to say example, sir, we can create a virtual laboratory for a mechatronics lab, sir. So we can create a virtual laboratory for a thermal engineering, sir. We can create a virtual laboratory for a engineering graphics, sir. So this is the main motto of this induction program. Okay. So with which I thank you each and everyone for your presence and your time you have been utilized for this session. Okay, thank you. Can you tell again, Deepak?
Sir, we have confidence to proceed further, sir.
Yes, since it is similar to that of working like a physically. Am I right or wrong?
Yes, sir.
Okay.
It is physical working, sir.
Okay, it is similar to that of a physical touching. Okay.
Yes, sir.
Is there anybody else you can say your suggestions and your feedback?